or down, up or down. We have a tree of the way the stock behaves. Again, this is binomial split, which if you have these intervals short enough, will approximate the continuous world. Again, if you remember your algebra or some level of math or whatever, in that it shows that the binomial approximation, the binomial world, when the intervals are short enough, approximate a continuous world. Now, then the way you price this, say this is the terminal value. Actually, these nodes, this tree will go on further out. And you know what the various S's will be based on the parameters of the model. You can calculate the U's and the D's, the up moves and the down moves, based on what volatility is, interest rates are, and so forth. Then you have these S sub 1s, S sub 2, S sub 3, S sub 4 here. And the way you solve the American option pricing model, once you get all your S's, S sub J's, if you will, from 1 till N, then you say at maturity, the call will be worth S sub 1 minus X, maximum of 0 or S sub 1 minus X. That is to say, maximum of, if this ends up in the money, then this will be worth S sub 1 minus X. If this ends up out of the money, this node will be 0. And you go down and you calculate the values of these nodes at these various stages of the world. That's what you do in your computer program. So you calculate all these. So S sub 1 minus K will be C sub 1. S sub 2 minus K will be C sub 2. So we'll get all these C sub 3s, C sub 4s. Then you go back one stage and you say, here the call is worth the probabilistically discounted value of C sub 1 and C sub 2. So it will actually be P1, that is the probability of C sub 1, plus P1 times C sub 1 plus P2 times C sub 2 over 1 plus R, 1 plus the rate of interest that is relevant to this period. This will be the value of the call here, and then you compare that to the value of the call if you exercise it early, to the node value here if you exercise it early. And depending which is bigger, you assign a value, and you go all the way back, and then you find your American call option price. And you have interest rates and dividend payments here, and even if they are stochastic, you can introduce it into this tree, and this is no longer a closed form solution, but a numerical solution, that meaning that you can introduce any sort of complexity, any sort of awkward behavior into your diagram. That is the basis of pricing American options. Now, what do we do? What do we do if we have an option on a futures and we want to use the Black-Scholes formula? Again, that's not very difficult either. What you do is you replace the S in the Black-Scholes formula with F times e to the minus RT, where F is the future rate, E is the natural number, R is the interest rate, and T is the time to maturity. Why? Think of it intuitively. Okay? In the Black-Scholes formula, you have S there because S is what you pay to maintain the riskless hedge portfolio. Okay. Well, what about with a futures contract? First thing is that how can we convert the S in the Black-Scholes formula to what you would pay in a futures contract? Well, in a futures contract, you don't pay F till time to maturity, right? And therefore, the current value of that F is F times e to the minus RT, or F over 1 plus R to the minus, no, 1 plus R to the T if you're not using continuous compounding. And that's what you do. And if you do that, you get the formula for a futures price, and this gives us the so-called black formulation, the 1976 paper. But that's the intuition. When do we use futures prices? Well, we are in the business of writing options on interest rates, right? So what are we here currently? This is March, June, September, December, right? Say somebody wants to buy an option to borrow money from us today in March 17, starting in June for 3 months, right? Starting in June for 3 months. Somebody wants to borrow money from us, 3-month money, starting in June. Well, how are we going to hedge that? We're going to hedge that in the euro-dollar futures market, if we don't take it into our gap. We're going to hedge it in the euro-dollar futures market. So what is this? This is a euro-dollar futures contract. To the extent that we can price a June euro-dollar futures contract, then we know what the value of that option that somebody wants from us is, right? Now remember, a call option on money is what? It's a put option on bonds. And a call option on bonds is a put option on money, right? If you want to call money, if you want to borrow money, you're putting bonds, you're selling bonds, right? And if you want to invest money, you're buying bonds. Okay, if you want to put money, you're calling bonds, right? Remembering that distinction, actually, any interest rate option, not any, but if somebody wants to borrow, the right to borrow 3-month money at a certain rate starting in June for 3 months, we can convert that to an option on a euro-dollar futures contract, and that's how we price it. Okay. Other questions? Okay. How about foreign exchange? Again, for the sake of completeness, just for your own curiosity, remember that in foreign exchange, the forward rate always evolves such that we have S times e to the RT, e to the minus R star t. Okay, the forward rate evolves as a function. This is the natural. This assumes continuous compounding, right? This is the current interest rate in local currency, and this is the foreign interest rate. All right. This is the exchange rate in local currency per foreign currency, right? If the home interest rate is higher than the foreign interest rate, the forward rate in local currency per foreign currency will be higher than the spot rate, right? That is to say, if we are paying higher interest rates than Germany, then the dollar should be at a forward discount, right? And that's why this formula holds. So can we use the Black-Scholes option pricing formula for foreign exchange? Yeah, we can, but we have to make the transformation that, see, the S in the regular Black-Scholes, we have to transform it to S times e to the minus RT. Again, why? In foreign exchange, again, remember, the value of the call option is the cost of maintaining the hedge portfolio. Now, if we have a stock and we buy the stock and it just sits in the hedge portfolio, however, with foreign exchange, it's not the same thing. We buy the foreign exchange, we buy a Euro-Deutsche Mark contract, it earns interest at the Deutsche Mark rate of interest. So the opportunity cost of buying that is actually less than S. So we can use the Black-Scholes pricing model for foreign currency options, provided that we make the following transformation. Okay, anyway, the message I want to give you is that these things, under certain assumptions, the original Black-Scholes pricing formula can be applied for other securities. For instance, if you have gold and gold has a holding cost, then instead of S in the original Black-Scholes model, we'll have S times e to the GT, where G is the holding cost, the continuous holding cost. Are there any questions? Okay, if there are no more questions, I don't have much more left to say.
Thank you.
Okay, thank you.